Natural log of 7,957 is just a simple number. So all I have to do is move 1. You can put it in front or behind, it doesn't matter. And then what will I have to do to solve for x? Good. I will divide step by step, term by term. -1 divided by -8 is 1 over 8. And then -1 over 8 times natural log of 7,957. And this is it. Yes, you can approximate it, putting in the graphing calculator, approximate it, and put it back in the equation to make sure that there is no mistake. You would like me to do that, or you can do that. Okay, let's please make a choice. You want me to show it, or you're fine and you're able to do that? We showed it several times last time, but it doesn't matter. You want me to show this? Yes? Okay. I saw one yes, so let's do it. Okay. Now, let me look and see what was the equation. What was it? Was the original. Okay, so I have to copy it. So this is e to 1 minus 8x equals 7,957. Okay. So in the graphing calculator, let's put in negative. No, it's not negative. It's 1 over 8. No parentheses are needed in 1 over 8. Minus, in parentheses now, 1 divided by 8. Close the parenthesis. Natural log 7,957. Close the parenthesis and press enter. So this is the approximation, and you can copy it down. Now, in order to check, I would do this. Second and E. Yes, Juan, any questions? Go ahead. Is this okay? You may have a question that other students have it the same, and they, you'll help me and you'll help everyone else. Is this okay? How we got this number? Okay, so I have E in parentheses. The equation is 1 minus 8, 1 minus 8, and I recall the previous answer and close the parenthesis. That's our x, the previous answer. And then I will subtract 7,957. And when I hit enter, if I don't get 0, I will say something is wrong. That is not the correct solution. So let's check. Now I press enter, and okay, so I have something in there. Let's see what I did. I don't see any problem. But I'm going to do it again with parentheses around 1 over 8. Let's see why. So we had 1 over 8 minus 1 over 8 times natural log. If you got the answer and the software didn't work, please let me know so I don't have to waste the time. Did it work with your calculators? Okay. So I have E in parentheses. It was 1 minus 8x, 1. Probably I didn't put a multiplication symbol, so let me put a multiplication symbol. Maybe that's why. Copy the previous answer, and then minus 7,957. Probably that was the error. Okay, it didn't like, the software did not like it without multiplication symbol between -8 and the previous answer. So then we know that this is the correct solution. And I can copy approximation -0.9977259. Okay, so now let's look at the expanding. Let's look at problem 38 on page 501. And we have natural log, bracket, x to the 4th, the square root of x squared plus 3 everything divided by x plus 3 to the 5th power. Okay, so I look at this and I see three quantities. I hope you agree with me. I see a quantity that is x to the 4th. I see another quantity that's the square root. And I see another one in the denominator. When I'm done, which and how many logs will have minus in front? Just one? Just the one from x plus 3 to the 5th. Okay, can we use the shortcut? If you say, no, I'm not ready yet, show me step by step, then I'll show step by step. The shortcut would be natural log of the first quantity plus natural log of the second quantity minus the natural log of the denominator. Would that be okay? Or you want to, yes, is that okay? So this will be natural log of x to the 4th and plus natural log of the square root x squared plus 3 and minus natural log of x plus 3 to the 5th. And now all I have to do is apply the power rule. Let's apply the power rule on the first one. That's it. Now the power rule on the square root. We know the square root is not power 2, but 1/2. So this is plus 1/2 natural log of x squared plus 3. And the last one will be minus 5. Let me caution you because it's tempting. Let me caution you on something. Natural log or any log in any base of a plus b cannot be simplified in any way. So this is a sum. This is it. So this does not equal log of a plus log of b or anything else. The same thing here. This is it. You cannot further simplify log applied to a sum or a difference. Remember the same thing with the square root. I can take the square root from AB and simplify it if you want like this. But if the quantity underneath is a sum or a difference, I can no longer do anything. Same thing here. So the log function has only three properties: for a product, for a ratio, and for a power. Not for a sum, not for a difference. I know it's tempting, but you can't simplify this any further. This is it. Marcus, is that what you had in mind? Is this good enough? Okay, stop me if you have other questions. Okay, so let's go back then to section 4.4, in which we are trying to see if there is anything else, other types of exponential equations. Yes, so let's look at 41. I would consider this the most difficult one, type of exponential equation. 5 raised to 2x plus 3 equals 3 raised to x minus 1. So the first question I'm asking myself, what is it? And the answer is it an absolute value equation, a quadratic, a linear, rational, cubic? It is exponential. The variable is at the exponent level and nowhere else. Of course, thank you. Good. Now my next question to myself is, can I present both sides with the same base? Because if I can, it's not that difficult. So is there a way of presenting 5 and 3 with the same base? No, there is no way. So my only chance to bring this number or this quantity or this expression in front, or in other words down, so I can solve, is if I apply, since these two are two equal numbers, their logs in the same base will be the same. Only because they are the same. So it's like 10 equals 10. Log of 10 will be log of 10, right? So which log you want to apply? If these bases are 10 or e, we know exactly which one to apply, right? If it's 10 here and 3 here, I will apply log 10, common log. If I have 5 here and e here, I will apply common log to both sides. But 5 and 3, and I will not apply log base 5. I will not apply log base 3. I will apply one or the two that I have in the graphing calculator, either base E, natural log, or 10, common log. Which one? It doesn't matter. The answer will be the same. ln is easier to write than log. So it doesn't matter really. Which one? We just have to make a decision. Okay. So now I have to be very careful how I continue, because I have to bring the power in front. And if I omit to put parentheses, I'm in big trouble, because I changed the problem. So when I bring that power, because it's two terms, if it were one term, I didn't need to put parentheses, but it is two terms. It's consists of two terms. So that's why I have to put in parentheses. Now, please, one more time, do not get discouraged or afraid of this. This is just a number. It just happens to have ln in front of it, but it's just a simple number. We are interested in x, and I have two numbers here. What should I do first? I have to distribute. This is a number. If you don't like a natural log 5, just put a in there. If you don't like natural log 3, put b. But we have to distribute them. So 2x natural log 5 plus 3 natural log 5 equals x natural log 3 minus natural log 3. I have to distribute. Why am I distributing? Because I'm solving for x. And now I have to have the terms with x only on one side, not on both. And I have to move terms without x to the other side. This is a linear equation. It's not a natural log. It's not a log equation. There's no x inside log. This is just linear. So I see this term with x and this term with x. They have to be on one side. I see this term with no x. It has to go to the other. So the left-hand side is 2x natural log 5 minus x natural log 3. Negative natural log 3 minus 3 natural log 5. We're solving for x. We cannot combine like terms. They are not like terms because of those natural log 5 and natural log 3. But there is a way. What would be that? We've done that many times before. When I cannot combine and I have to solve, what is my choice? No, not in this case. I have to combine like terms. I can't. So then if I can't combine like terms, what is the only way? It's one of the key words that we started with from the very first day. One key word is simplify, and the other key word is thank you. So which one is it? Which one will I apply here? Since I can simplify, what am I factoring out? No, because this is a number and this is a number. What do these terms have in common? Of course, I'm after x. So what is left in parentheses? Remember, just to make sure this is together, you cannot separate. You cannot separate these two. The ln is the function and 5 is the argument. The ln is the function and 3 is the argument. So then what is left in parentheses? X is outside. 2 ln 5 minus. Very good. And now you know what to do to get x. Please tell me, what do I need to do to get x? Remember, this is just a simple number. It looks very sophisticated, but it's not. It's just a number. Divide by it. So negative natural log 3 minus 3 natural log 5 over 2 natural log 5 minus natural log 3. Nothing can be simplified. Don't try anything. Would you feel more comfortable if we would work on another one? Do you want to approximate? We can approximate and go back and check. Do we want to approximate and check, or we want to look at another? Another one? Okay, very good. So let's look at 42. 7 raised to 2x plus 1 equals 3 raised to x plus 2. What will be the first step? Well, identifying the type of equation. We know what it is, because the variable is nowhere else but at the exponent. It must be an exponential equation. Okay, next question. Can I present 7 and 3 with the same base? Because if I can, I don't need to do what I did before. But I can't. 7 and 3 cannot be presented with the same base. So then what do we need to do? How do I bring that power down? Only if I apply natural log to both sides. Okay, then the first step would be, after I apply log to both sides, what do I need to write? Yes, very good, but it has to be in parentheses, because if I don't put it in parentheses, then 2x plus 1 would not be a factor. Only 1 will be a factor if I don't put parentheses. What about the other side? Yes, perfect, and in parentheses, natural log 3. Perfect, awesome. Next step. What do I have to do? See, x is right here, hidden in here, and hidden in here. I have to get to it. Distribute. 2x natural log 7 plus natural log 7 equals x natural log 3 plus 2 natural log 3. Next step. Yes, x's have to be on the same side, natural log, without x on the other. So 2x natural log 7 minus x natural log 3, negative natural log 7 plus 2 natural log 3. You could condense these, but there is no point. There is no need to condense them. Yes, what do we factor out? Perfect, because we cannot combine. 2 natural log 7 minus natural log 3 equals negative natural log 7 plus 2 natural log 3. Awesome. Therefore, the last step, x equals. Again, this is just a number. Now let's approximate this one and check this one so you see how it's done. Because we really need to be very careful about parentheses. So let's do this. You know, my best friends, right? Okay, parentheses around the top. Negative, we start with a negative sign. Natural log 7, close the parenthesis. And then plus 2, natural log 3, close the parenthesis for the natural log, and close another parenthesis for the top. Okay, now divided by parentheses. 2 natural log 7, 2 natural log 7, close the parenthesis, and then minus natural log 3. Close the parenthesis and close the whole entire parenthesis for the denominator. Now I press enter and I get something. Okay, so the approximation is 0.08997. But I'm not going to use the approximation in checking. So I'm going to do this. The equation was 7 caret in parentheses 2 multiplied by the previous answer plus 1, close the parenthesis, and then minus 3 caret parenthesis. It was x plus 2, which is the previous answer, plus 2, and close the parenthesis. Now when I hit enter, what should I get if the solution is correct? And I don't, yes, I should get 0, right? That's what we did. So let's see. Yes, which means that If I'm asked to present the exact solution, this is the exact, and I don't have to do anything else. And this is the approximation. But I will not use the approximation to check my answer, because then I'll get some error, right? It has to be. If I don't use the entire number, the calculator will not give me exactly 0. It will either give me negative 0.001 or positive 0.005, right? Okay, are we okay with this type? Okay, so now let's look at logarithmic equations. What did I say about the exponential function? It is friendly or it's not friendly. The exponential, very friendly. Defined everywhere, like the polynomial function. I don't have to worry about it. What did we say about log? Not friendly. Like the square root or like the rational function is not defined. Sometimes it could be. I'm not saying always, but I have to worry about the domain. So we will worry about the domain. We did not have to worry about the domain before when we solved exponential equations. Anything goes. But here we have to worry about the domain. So here's the point I'm making. When we solved radical equations, what did we do with the solutions? Remember when we take, let's say the square root of x equals 2, we squared both sides, and we got x equals 4. What did we do with this before we said yes? Yes. So with log equations, we have two options. First option, do not forget to check. Check all prospect solutions, like with the radical equation, back in the original problem or equation. There is a second option. So the first option is, every time I solve a log equation, I check all prospect solutions back in the original problem or equation. So I check prospect solutions back in the original problem or equation, like we did with radical. Here's a second option. No one is forcing you to use one or the other, but you have to use one or the other. I prefer the second one. I find domain and check against the domain. We're going to use the second one, but you don't have to. But you have make yourself a mental note. When I solve radical equations and when I solve logarithmic equations, I must go back and check. Okay? If you don't like to find the domain, I will use this method. And you'll see why in a minute. You use the method you like. So first log equation. Let's start with a simple one, like 60. Log base 2 of 4x plus 1 equals 5. What could be the domain of this function? Forget about the fact that it's an equation. What do I have to write to find the domain of this function? Let's say I'm given this function, I'm asked, find the domain. Don't do anything else. What do I have to write and solve? Same idea with the radical equation, square root, with the radical function. What do I have to write? I have to write that 4x plus 1, the quantity that log is applied to, must be positive. It's like with the square root, right? So if I have the square root of x plus 1, what do I have to write? That x plus 1 is greater than or equal to 0. Here, it's a log function. I cannot set it equal to 0. So I have to write that 4x plus 1 is greater than 0. Otherwise, log does not exist. So then I move on. 4x greater than negative 1, x greater than negative 1/4. So I know that the domain of this function is negative 1/4, 0. So if I find a solution that is negative 10, I will not have to go back to the original problem. What will I conclude? It's not possible. It's not a solution. What if I find a solution that is positive 3? I don't have to go back because I know it's right. Okay? So I don't know how to solve this, but I know it can be replaced by an exponential equation. Base raised to the 5th power is this. So 2 raised to the 5th equals 4x plus 1. How much is 2 to the 5th? Very good. Equals 4x plus 1. I subtract 1. This is linear now. 31 equals 4x. X is 31 over 4. I put a question mark because I have to check. But I don't want to because I have domain. Is this in the domain? That's all I have to do, and I'll say yes. But I accept if you say no, for me it's much longer to find the domain. I'll rather go back and check. That's fine. But if you omit to check, then you cannot get full credit. So I recommend this method if you like it. Okay, so let's take a look at another. Let's say 70. Same page, 515. Log base 6 of x plus 3 plus log base 6 of x plus 4 equals 1. Okay, what type of equation is this? Is it absolute value? Is it radical? Quadratic? Of course it's log. Correct. Good. So now I see two functions in this equation. What condition do I have to state for the first one, like we did with rational functions? Very good. X plus 3 must be greater than 0. What condition do I have to write for the second log to exist? Perfect. Awesome. So then this one says x greater than negative 3, and this one says greater than negative 4. Remember common domain from chapter 2? Common domain, meaning they have to overlap. If they don't, we will never be able to add them. So if it's easier, you don't have to graph, but if it's easier for me to explain what I'm doing. So the first one says greater than negative 3. Here's negative 3. Greater than negative 3 is this portion of the real line. The other one says greater than negative 2. Negative 4. Negative 4 is here. So now I need to choose both colors where both functions are defined at the same time. So the common domain is negative 3 to infinity. If I do not get a solution, not negative 3, but between negative 3 and infinity, what will I conclude about this equation? No solutions. Okay, very good. How do I condense? That's why we did the condensing last time for this. How do I condense log base 6 of x plus 3 plus log base 6 of x plus 4? It's log base 6 of very good indeed. Perfect. Because log of a product is the sum of logs. Awesome. Now I don't know how to solve, but I do know that this is equivalent to an exponential equation. Base, counterclockwise. You start with the base and then you go counterclockwise. Base to the, yes, base to the first power equals this product. I'm going to expand it. It's x squared plus 4x plus 3x plus 12. Because I need to multiply it anyway. Why write it twice if I can avoid it? Okay, so initially it was a log equation. Now what type of equation is this? Quadratic, indeed. See why I repeated myself like a broken record for a month and a half? Good. We're making progress. So this is x squared plus 7x plus 6 equals 0 because I have to move 6 to the other side or subtract 6 from both sides. I know 4 methods of solving quadratic equations. Complete the square? Absolutely not. Taking square roots, I can't. It's not set up. So I'm down to 2. They are quadratic formula or factoring. If factoring takes 30 seconds or less, I'll do it. Otherwise, quadratic formula. Can I factor this? How do I do it? So x plus 6, x plus 1, you're right. I know what you're way ahead of me. Awesome. So then x equals? Very good. But remember a big question mark. But I don't have a lot of, there is not a lot of effort here now because I know the domain. And what will I say? I don't have to go back and check. This is the only solution. The other one, either one or both logs will not be defined. Okay, let's look at another. Okay, 72. Log base 4 of x plus 2 minus log base 4 of x minus 1 equals 1. I see 2 logs. I have to find their common domain to see where they both exist. And then I'll decide how to condense. What is the condition of existence of this one? Meaning this one. What about this one? X minus 1 greater than 0. From here, I have greater than negative 2. From here, greater than 1. You don't have to picture this in your head. You can draw it. But look at what the first one says. From negative 2 to infinity. The other one says from 1 to infinity. Where is the common domain? Yes, the common domain is 1 to infinity. If I don't get solutions, or a solution between 1 and infinity, I'll say the equation has no solutions. Now I have to remember how to condense a difference of logs in the same base, or with the same base. Awesome, thank you. That is the quotient rule. I have no clue how to solve this, but I know it changes into, there are other ways, of course. So I can change this into an exponential equation. Always start with the base and go counterclockwise. Four to the first power equals x plus 2 over x minus 1. Now the question is, what is this? Because it's not quadratic, it's not linear, it's not exponential, it's not log, it's not absolute value, but what is it? Rational. And here is my hint for you. And we remember this vividly, I hope. Proportion, very good. So 4x minus 4 equals x plus 2. Remember, I cannot beg you enough to redo all tests with solutions every weekend for the next 5 weeks. You will be very happy if you do this. And you will make me very happy. So now what type of equation is this? Is it quadratic, rational, radical, linear, of course. Subtract x, 3x, add 4. So get x equals 2. It comes with a question mark. I go back and I see 2 is in the domain. So I'm done and I will say yes. I think we should look at one more. And then let's discuss why. Basically, why we learned how to solve exponential and log equations. Of course, if you want me to continue and practice, we will. So here's another one, 89. Natural log x minus 4 plus natural log x plus 1 equals natural log x minus 8. Now I have 3 log functions. I will have 3 restrictions, and I will have to find the common domain. Okay. For the first one to exist, I will have to write perfect, otherwise log does not exist. For the second one, I have to write perfect. And for the last one, x minus 8. The first one says greater than 4, the next one says greater than -1, and the last one says greater than 8. Greater than -1, greater than 4, greater than 8. Where do I have all 3 colors? Greater than 8. So if the solution is not a number that is strictly greater than 8, the equation has no solutions. I have to condense the left-hand side. How do I condense the left-hand side? Perfect. Now I would like you to pay attention for a second. Forget about the equation just for one moment. When we looked at 2 raised to x plus 1 equals 2 raised to the second power, what did we say? We said this. 2 numbers are equal, and they have the same base. Therefore, the exponents have to be the same. In this case, I'm going to say, because see, this is different. So here's what I'm going to say now. 2 logs in the same base, 2 logs in the same base are equal. What has to happen to the quantities they are applied to? Can this one be 5 and this one 10? No, because natural log 5 does not equal natural log 10. So what has to happen with these 2 quantities? They have to be equal. Same idea, one more time. 2 numbers are equal, they have the same base, therefore the exponents must be the same. 2 logs, and this is a key, in the same base. Otherwise the problem is different. 2 logs in the same base are equal. They must be applied to the same number. Therefore, from here I have x minus 4 times x plus 1 must equal x minus 8. So I distribute x squared plus x minus 4x minus 4 minus x plus 8, and I move x minus 8 to the other side. This and this happens because both functions are 1-to-1. What type of equation is this? I should have asked that before moving everything to one side. You will say, very good. So these 2 go away. So I have x squared minus 4x plus 4 equals 0. This was the first handout we looked at on the first day of classes. Quadratic, what do I do? Yes, how? So then you can say there are 2 solutions, however, there is only one. Now, is 2 a number in the interval 8 to infinity? Therefore, this equation has no solutions. Any questions? Any questions?